Cosmic abysses. An introduction to black holes. Black holes, they're one of the most mysterious and intriguing things you'll find out there in the universe. When it comes to the most fascinating objects in the universe, black holes are right up there. Scientists and astronomers are captivated by their mysterious nature and their extreme properties. They're like regions of space-time where gravity is incredibly strong. We're talking seriously strong, so strong that it warps the fabric of space-time itself. Nothing, not even light, can escape their grasp. That's why black holes look black. They don't emit any light. You can't see black holes with telescopes that detect light, X-rays, or any other type of electromagnetic radiation. The only way we can detect them is through how they interact with the stuff around them. But there are ways to detect them indirectly. One way is through something called gravitational lensing. That's where the black hole's gravity bends light from objects behind it. We can also observe their effects on nearby stars and gas. These interactions can tell us if a black hole is there, even if we can't see it directly. Black holes come in different sizes, from small ones called stellar mass black holes to absolutely massive ones called supermassive black holes. Stellar black holes form when massive stars collapse at the end of their lives. This collapse causes a supernova explosion, and what's left behind is a really dense core. Supermassive black holes are millions or even billions of times heavier than our sun. You'll find them at the centers of most large galaxies. They live at the centers of most galaxies, including our very own Milky Way. The supermassive black hole at the center of our galaxy is called Sagittarius A. Black holes play a crucial role in how the universe evolves. Their massive gravitational pull can influence the movement of stars and the structure of galaxies. They influence star formation and how matter is spread out in galaxies. By shaping their surroundings, black holes contribute to the dynamic and ever-changing nature of the cosmos. The life and death of stars. Stellar graveyards. Stars, those bright lights in our universe, have amazing life cycles that last for millions, even billions of years. Stars are born from massive clouds of gas and dust called nebulae. These cosmic nurseries are where new stars come to life. Gravity pulls all that material together, making the gas and dust clump up and form really dense regions. As the cloud collapses, it heats up because the pressure and density inside are increasing. Eventually, the core gets so hot and dense that nuclear fusion ignites. That's the process that makes stars shine. This fusion process lets the star shine super bright, and it can keep going for millions or even billions of years, depending on how big the star is. Throughout their lives, stars are constantly battling between gravity pulling inwards and the outward pressure from nuclear fusion. It's a delicate balancing act. When a massive star runs out of fuel, that outward pressure stops, and the star starts to fade. Gravity takes over, and the star collapses really quickly under its own weight. This collapse triggers a supernova, one of the most powerful and brightest events in the entire universe. The core of the star keeps collapsing under its own gravity, getting denser and denser. If the core is massive enough, it will collapse into something called a singularity, a point of infinite density where the laws of physics go haywire. This singularity, hidden by an event horizon, is what forms a black hole, a mysterious and powerful object that warps space and time around it. A universe of black holes: stellar, supermassive, and intermediate. We classify black holes into three main types based on how heavy they are: stellar, supermassive, and intermediate. Stellar black holes are the most common type. They're formed when massive stars, at least 20 times heavier than our sun, collapse. Supermassive black holes are found right in the centers of most galaxies. They can be millions or even billions of times heavier than our sun, making them incredibly strong gravitational forces. Intermediate mass black holes are a bit rarer. They fit somewhere between stellar and supermassive black holes in terms of mass, usually ranging from hundreds to thousands of solar masses. Scientists reckon they might play a part in how supermassive black holes form, maybe by merging with other black holes or gobbling up mass over time. Studying these different types of black holes helps us understand how the universe has changed over time, shedding light on the life cycles of stars and what makes galaxies tick. Researchers use simulations and observations to uncover the mysteries of black holes, revealing their impact on the cosmos. Future telescopes and space missions are going to take our knowledge even further, giving us new insights into these enigmatic objects. Spaghettification and gravitational waves. Extreme physics at play. Black holes are all about extreme physics because their pull is so strong. One crazy thing that happens is spaghettification. Imagine falling into a black hole feet first. The gravity on your feet would be way stronger than on your head. This difference in force would stretch your body out, just like spaghetti. Another mind-blowing thing about black holes is gravitational waves. These are like ripples in space-time caused by massive objects, like black holes, smashing together. Back in 2015, scientists made a huge discovery. They detected gravitational waves from two black holes merging. This proved Einstein's theory of general relativity right, beyond the event horizon. Speculation and theories. The event horizon of a black hole is like a point of no return. Once you cross it, nothing, not even light, can escape. What's beyond the event horizon is one of the biggest mysteries in physics. Some theories suggest that black holes could be gateways to other universes or dimensions. These hypothetical connections, called wormholes, could be like shortcuts through space-time. But remember, the existence of wormholes is still just a theory. Other theories say that information that falls into a black hole isn't lost forever, but encoded on the event horizon. This idea, called the holographic principle, suggests that the universe might be like a giant hologram. Black holes' engines of cosmic power and influence. Black holes aren't just cosmic vacuum cleaners, they're also powerful engines that drive some of the most energetic stuff in the universe. As matter falls into a black hole, it forms what we call an accretion disk, a swirling disk of gas and dust that gets heated to insane temperatures. This superheated material emits intense radiation, including X-rays. Black holes can also shoot out powerful jets of particles at nearly the speed of light. These jets can stretch for thousands of light years, and they can actually influence how galaxies evolve. Earth and black holes, a cosmic perspective on potential threats. Black holes are fascinating, no doubt, but they could also be a threat to Earth. However, the chances of a black hole hitting our solar system are incredibly slim. The distances between stars are massive and black holes are relatively small, so a collision is very, very unlikely. Even if a black hole did come close to Earth, how much its gravity would affect us depends on its mass and how far away it is. Astronomers are always keeping an eye on the skies for any rogue black holes or other space objects that could be a danger to our planet. Unmasking the invisible advancements in black hole observation. We used to think black holes were invisible, but now we're studying them in more detail than ever before. The Event Horizon Telescope, a global network of telescopes, captured the first ever picture of a black hole's shadow back in 2019. This was a massive achievement, giving us direct visual proof that black holes exist. Scientists are also using gravitational wave detectors to study black hole mergers. These detectors can pick up the ripples in space-time caused by these cosmic collisions, giving us clues about the properties of black holes and the nature of gravity itself. Section 9. The Future of Black Hole Research. Unraveling the Cosmos's Mysteries. Black hole research is a field that's constantly evolving. Scientists are always working on new technologies and techniques to study these mysterious objects. Future observations with the Event Horizon Telescope and other telescopes will give us even more detailed pictures of black holes. Gravitational wave detectors are getting upgraded too, so they can detect fainter signals from black hole mergers that are further away. These advancements will help us solve the mysteries of black holes and figure out their role in the evolution of the universe. Black holes as windows to the universe. Black holes are more than just strange objects in space. They're like windows into the most extreme places in the universe. By studying black holes, we can test our understanding of gravity, explore what space-time is all about, and learn more about how galaxies evolve. As we keep exploring the vastness of space, black holes will no doubt keep fascinating us and lead to new discoveries.